Professor?
Yep.
So what's usually given if we want to find out R or the voltage?
The currents.
Yeah, the voltage is given or the resistance is given.
Okay, so we'll show you equations. I set the currents just to keep it simple, but anything. Okay, so let's see how many elements are there. 1, 2, 3, 4, 5, 6, 7 unknowns. So if everything was an unknown, you know from your math classes that you would need 7 equations to solve for the 7 unknowns. Okay. So generally what they do is, oh no, there are more unknowns. 1, 2, 3, 4, 5, 6, 7, and then the 3 currents, 10 unknowns. Okay, so if you want to know all 10 unknowns, you'll need 10 equations. So we'll show you how to set up equations. Generally, they'll just give you 6 or 7 of those. So in here it was these 3 unknowns, but you can have problems where they give you I1 and then E1 could be one of the other unknowns. Or they can give you E1, E2, I1, I2, and I3, and they can make R1, R2, and R3 unknowns. Okay, so any combination of unknowns. So, and they'll give you the rest of the stuff. I'll do an example in a second, okay? All right, so we want to solve a circuit like this, okay? So the 2 Kirchhoff's rules are the following. Okay, so in the circuit, first let's define some elements. This is an arm, that is an arm, this is an arm. When more than 3 arms meet, this is a junction. Okay, so that's a junction, this is a junction. This is not a junction. That's just one continuous arm. Okay, a current in the arm is the same. Okay, so a current in an arm. So here is the current flowing through this one is I1. The current in this arm is, we call it I2. And so they're just like variables, X, Y, Z. The current in this arm we call I3. All right, so the first Kirchhoff's rule says the current flowing into a junction. So here's the junction. So the current flowing into the junction, in this case, it's I1 and I2. So I1 plus I2 flow into the junction. So the current flowing into a junction should equal the current flowing out of the junction. In this case, it would be I3, okay? So that's the junction rule. Current flowing into a junction should equal the current flowing out of a junction, and which is just simple logic because you can't have current collecting, you can't have charges collecting at a junction. Whatever charge flows into the junction flows out of the junction, okay? So the junction rule tells you that in that case, in I1 plus I2 should equal I3. So for this problem, you have 3 unknowns and you have 1 equation from the junction rule. Okay. Generally, you want to apply the junction rule first to get equations to solve for stuff. Okay. So that's the junction rule. The second rule is the voltage rule. And so for instance, so here is another circuit. What you have to realize is at every point in the circuit, every point is at a specific voltage. So for instance, if this was a 12-volt battery, this point would be to 12 volts and this point would be at 0 volts, okay? And then every point from there on, so this point would be at a lower voltage, this point would be at a lower voltage and so on. Well, okay, so the 12 volts would have worked if that was a single, if this battery wasn't there, okay. So anyway, let me tell you what that means. Okay, so in this simple circuit, let's say this is an 18-volt battery. This point would be at 18 volts, and let's say this is 10 ohms, 8 ohms. Okay, And the current through this circuit will be 1 amp. Okay, so this point is at 18 volts, and you learn to solve this kind of stuff. This point will be at 18 minus 10, which is 8 volts, and this point will be at 0 volts. Okay, so every point in the circuit is at a certain voltage. Okay, what Kirchhoff's rule says is the change in voltage across all elements. So that's what that term is, change in voltage when you cross an element. The sum of change in voltage across all elements around a closed loop is 0. Okay, and that makes sense. So let's say this is at, we'll just make up a number, 20 volts. You go across this element, the change in voltage is plus 4 volts, so, and so on. When you come back, the change in voltage across each element, if you add them up, you come back to the same voltage. So the sum of the volts change in voltage should be 0. Okay, let me say it another way. Imagine this is a mountain and you're going around the mountain for a hike. The change in elevation for every journey should add up to 0 when you come back to your starting point. Okay, and that's what that is saying. Okay, so change in voltage across each element adds up to 0. All right, so let's go through these elements and these slides, and then I'll do an example for you guys. Okay. Now, what this diagram is showing you is when you go across a resistor, if you're traveling with the current flows from a higher voltage to a lower voltage. So when you go across this element, the change in voltage is negative IR. You're going from a higher voltage to a lower voltage. So the change in voltage across this element will be negative IR. If you're going against the current, so in a circuit, if you're going against the current flows again from higher to lower voltage, so you're climbing uphill. So the change in voltage across this element is plus IR. For a battery, if you're going from the negative to the positive terminal, that's what the direction of travel is, the change in voltage is positive. So this point is at a higher potential than this point by that amount, by V. If you're going across the battery from a positive to negative terminal, this point is at a lower voltage, and so the change in voltage is negative V. Okay, so those are some of the things you have to remember. Again, simply remember, going with the current, it's minus IR. Going against the current, it's plus IR. Going across from negative to positive voltage, it's plus V. And if you go from positive to negative, it's minus V. Okay. So to solve circuit problems, the number of independent equations needed equals the number of unknown quantities. So if you have 3 unknown quantities, you need 3 equations to solve this equation. And the appropriate quantities will be given. So the 3 quantities can be, you can get the 3 equation from the junction rule, and then you can apply the loop rule to one of 3 loops. Here's one loop, here's another loop, and there's another loop. Okay. So the 2 Kirchhoff's rules can give you 4 equations for this circuit. Okay. So you can, in principle, solve for 4 unknowns, and the other rest of the quantities will have to be given. Okay. All right, so those are the Kirchhoff's rules. So let me now solve a problem. Okay, so let's make up a problem. All right, so let's say, okay, I'm just going to make up numbers. So let's say this is 12 volts, this is 18 volts, this is 10 ohms, 20 ohms, 30 ohms. Okay, so let's say what we want to do is solve the circuit, meaning we want to find the current through each element. Okay, So we'll just label them with variables. We'll call this I1. We'll call this current I2 and current I3. So now solving the circuit means finding I1, I2, and I3. Yep. So now you have three unknowns and you'll need three equations to solve this. Okay. The easiest equation to write down is the junction, using the junction rule. So here's the junction. So we know that current flowing into the junction should equal current flowing out of the junction. So I1 plus I2 should equal I3. Okay, so the first equation we get is I1 plus I2 is equal to I3. Okay, that's one easy equation. All right, we need two more equations. So what we'll do is we'll apply the loop rule. This can be loop 1, this can be loop 2, and this can be loop 3. Okay, going around the outside. Okay, so that's loop 3, here's loop 1, and here's loop 2. And by the way, you can traverse a loop in any direction you want. It won't matter. It'll give you the same equation if you travel one way, and if you travel the other way, it'll give you the same equation multiplied by a minus sign, which is the same thing. Okay. All right. So what we'll do is I will write down two more equations using. So you can use. All we need is two more equations, so you can choose two of the three loops. Okay. So what I'll do is I'll choose this loop and that loop. Okay. Or I'll use this loop and this loop. Okay. All right. So let's write down the equations. Let me make a room here. So I'm going to erase this. And I'm going to move this a little there. Okay, that's equation 1. All right, so for loop, I'm going to do loop 1. Okay, what I'm going to do is I'm going to start here. Okay, and I'm going to go across each element, the change in voltage across this element plus the change in voltage across this element plus the change in voltage across this element should equal 0 when you end up at the starting point. Okay, again, when you do the loop rule, so here the loop rule, change in voltage across each element should add up to 0 for when you traverse the loop. Okay. All right, so what we're going to do is we're going to start here. And when you go across this element, you're going from a lower voltage to a higher voltage. So the change in voltage is plus 12 volts. So when you go across that element, it's 12 volts. And then the next element you're going across is this element. You're going with the current. Current flows from a higher voltage to lower voltage. So change in voltage would be negative I1R. So it would be negative 10, R is 10 ohms, I1. Okay. The units for each term are volts, so I'm not writing the units just so it doesn't become too cluttered. Okay. And then you're going across this element, again, current, you're going with the current, so change in voltage across this element would be negative 20 I3. Okay. And now you come back to your starting point. So this sum of all these changes in voltage should equal 0, like the equation says. All right, so here is equation 2. Yeah. Now let's apply the same thing to loop 2. Okay. All right, so now we'll start here. Again, it doesn't matter where you start, and it doesn't matter which way you traverse the loop. Okay, so we'll start here. We'll go across this element. So you're going from low to high voltage, so it's plus 18 volts. and then you're going with the current. So you're going from high to low voltage, it's minus 30 I2. And then again, you're going with the current, it's minus 20 I3. Equal to 0. Okay, so there's the third equation. And you should be able to solve these three equations, three simultaneous linear equations in three unknowns. Okay, so let me write them, these equations here. I1 plus I2 equal to I3. That is equation 1. This equation, I'll clean up, I'll bring the two terms to the other side, divide by 2. Okay, so anyway, now I'll just bring it to the other side. Okay, so 10 I1 plus 20 I3, 10 I1 plus 20 I3 is equal to 12. Okay, that's equation 2. And this third equation says 30 I2 plus 20 I3 is 18. 30 I, oops. That's your third equation. Okay, and now you can solve. So you've learned various techniques to solve these equations, and so there. Now you have a solution to this circuit. You've solved the circuit, meaning you know the currents through each element. Okay. Do you guys want me to solve these equations? Okay, or do you guys know how to do this? Do you want me to solve this? Huh?
Yes, please.
Okay. All right, so now let's solve this equation. So again, in solving all these equations, all those techniques that you learn amount to the following: three unknowns, three equations. You solve it sequentially. You reduce it to two unknowns, two equations, and then one unknown and one equation. Again, so effectively, that's what they amount to. Okay. So what we'll do is the following. What we'll do is we'll substitute for I3 from here in there. And then these two equations will only involve I1 and I2. Okay. And that will have achieved this step going from there to there. So I'm going to substitute for I3 there. Okay. So 1 in 2 and 3. Okay. So 10 I1 plus 20 I1 plus I2 equal to 12. So this is 30 I1 plus 20 I2 equal to 12. Yeah. And then when we substitute I3 there in this equation, 30 I2 plus 20 I1 plus I2 equal to 18. So 20 I1 plus 50 I2 is equal to 18. All right, so now we have equation 2 prime and 3 prime. So here we have two equations and only two unknowns. Okay, so we've achieved this step now. And now we'll have to go to one equation and one unknown. Okay, so what I'm going to do is write these terms on the next page: 30 I1 plus 20 I2. Well, and the other equation was 20 I1. Okay. So now you have two equations and two unknowns. So we have achieved this step. Okay. All right, now simple trick to do is, okay, we can multiply this by this equation by 2/3, and that will make this 20. Okay. So we'll multiply this equation by actually by minus 2/3. Okay. So this equation becomes minus 2/3 minus 20 I1 minus 40 by 3 I2 and equal to minus 8. Okay. So there is equation, we'll call it, again, we'll just call it 2, and here's 3 again, or 2 double prime, 50 I2 equal to 80. Okay, 3 double prime. And the reason I did that is, now it's clear. You can see that now if you add these two equations, this term will drop out and you'll end up with an equation with one variable. So let's add the two equations, and what you get is 0 plus this is 150 by 3, so this is 110 by 3 I2 equal to 10. Okay. So there you go. This is one equation with one unknown, which is that step. Okay. And now this, even I can solve. So let's solve this. So I2 is 30 divided by 110. 3 over 11 amps. And then you can substitute this value in any one of these equations and solve for I1. And once you have I1, then you can solve, put it in there and get I3. Okay. So that's what solving a circuit means. Okay. So again, let me summarize this. Okay. So what we had was, we had a circuit like this, which had multiple sources and so on, and resistors connected like this. What you wanted to do was, when somebody asks you to solve a circuit, what they wanted to know is what is the current through each element. Or you can change the problem, they can give you the current and solve for the voltage, it doesn't matter. But so that's what you want to know. You want to know the current through each element, for instance. Okay. So to solve for the currents, what you used was, you used the junction rule, which says the current flowing into a junction is equal to current flowing out of the junction. So the two rules you use is current flowing into a junction is equal to current flowing out of the junction. And the sum of the voltages across all elements in a loop should add up to 0. With these two rules, we set up these three equations for the three unknowns, I1, I2, and I3. And we were able to solve for the circuit. Okay. All right. Good time to pause again. I'll let you guys ask